So at this point we have talked about adding and subtracting rational expressions. We've talked about finding the least common denominator. And now the last thing I want to talk to you about for this week is complex rational expressions. A complex rational expression is a ratio of two rational expressions. So, for example, 1 plus 1 over x over 1 minus 1 over x. So this is a rational expression and that is a rational expression. And what we're going to need to do in this chapter is figure out how to simplify these whenever possible. Let's take an example. I'm going to take practice number 1 on page 470. Page 470, practice number 1. They give us n minus 1 over n divided by n minus 1 over n squared. This looks really complicated, but remember these are just two ratios. This is a ratio up here, this is a ratio down here, and this is the main divider line. There's two ratios being divided by each other, one being divided by the other. First thing we're going to do here is rewrite this as a multiplication. So what this means is n minus 1 over n, right here, this is being divided by n minus 1 over n squared. This is exactly the same. This is just a different way of writing exactly the same thing. Remember, when we're dividing fractions, same thing as multiplying by the reciprocal. So I'll take my n minus 1 over n, and instead of dividing by n minus 1 over n squared, I'm going to multiply by n squared over n minus 1. When we're multiplying, now we want to multiply numerators and multiply denominators. But I'm going to notice right away that my numerator up here is the same as my denominator down there. Therefore, this and this cancel. I'm also going to notice that I have a factor of n down here and a factor of n times n up here. So I'm going to factor out one of these n's, cancel it with one of those n's down there. That leaves me with n. Let's do another example. Say we have 1 over y plus 3 over y squared all over 2y. Now in this case, we have two rational expressions being added together, and then that is being divided by another rational expression. So the first thing I'm going to do is actually simplify this addition. I'm going to put this in terms of a least common denominator so that I can add these two things together. So this is all going to be over 2y. My least common denominator between y and y squared is going to have a y squared, and it's going to have two factors of y. So I'm going to go y squared. But in the case of this first fraction here, I multiplied my denominator by another factor of y to get that y squared, so I'm going to have to multiply my numerator by a factor of y as well. Then if I were to cancel both the y on top and the y on bottom, I would be left with 1 over y, which is what I started with, so that's fine. Here I didn't have to do anything to my denominator to get it into like terms with the other fraction, so I'm just going to leave that as is. Now I can add these two. This will give me y plus 3 over y squared, and this is all over 2y. Now I'm going to turn this around. Well, I'm going to write it first as a division problem. So y plus 3 over y squared, that's my numerator right here, divided by my denominator, divided by 2y. And remember, dividing by something is the same thing as multiplying by its reciprocal. So I'm going to flip this upside down. Y plus 3 over y squared times the reciprocal of 2y, which is just 1 over 2y. And now I can multiply the numerators. That gives me a y plus 3 up here. And I can multiply my denominators. Remember, when you're multiplying, then you don't have to be in terms of least common denominator. You're multiplying the denominator, so we'd have 2y cubed